Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. This is a recorded lecture for chapter 6 decision analysis in management science 2. So what we will learn in decision analysis is how can we make decisions of any things, okay, based on a certain criteria. So there are two types of decisions problems. The first one is the non-probabilistic and the second one is the probabilistic. So for this chapter, we only cover for probabilistic problems. So probabilistic, which is consider the probabilities of uncertain events and select an alternative to maximize the expected payoff, or we want to minimize the expected loss. So having a probabilities of uncertain event. So that is probabilistic problems regarding to the decision criteria. Okay. So when we are making decision with probabilities, so we need to calculate the expected value. Remember, probabilities is always referred to expected value. Okay. When probabilities are available, the expected value approach is used to identify the best decision alternative. So this is the formulations for the expected value, which is equal to the summations of P times with V. So P is the probabilities of state of nature as J. V stand for payoff corresponding to the decision alternative. Payoff is like the profit. Okay, and stand for the number of states of nature. So we need to calculate the expected value. And then we will learn about expected value of perfect informations. So this is stand for EVPI short form. So what is EVPI? So EVPI is the maximum amount the investor would pay to purchase perfect information from another source, such as an economic forecaster. So what is the formulation for EVPI? Is equal to the modulus, okay, without having negative answer, EVWPI minus EVWOPI. So EVWPI stands for expected value with perfect informations. EVWOPI stands for expected value without perfect informations. So perfect informations means that you assume that the event is perfect. So when the event is perfect, so that means you will have the best payoff. You will have the best profit. So that is expected value with perfect information. Okay. With perfect information, we assume for each state of nature, we having the perfect profit, the perfect payoff. Okay, so that is EVWPI. So EVWOPI is we not assuming the perfect information, so it's the normal calculations. Okay, another one is when we have additional informations. Okay, because we know that for every state of nature, the chance to happen, the probability to happen is we have the value for the chance to happen. With additional informations, okay, so we will have another new probability of the state of nature, the chance the state of nature to happen with two conditions, okay, under the having a favorable condition or having unfavorable conditions. So these are two conditions when we have additional informations. So earlier what I say, this is having perfect informations, okay, but we note that if perfect information could be obtained regarding which state of nature will occur in the future, the decision maker could make better decisions. Okay, although perfect information about the future is rare, it is often possible to gain additional information to improve the decisions. So additional information is imperfect. It's nearest to perfect, but it's not perfect, because we know that have to get the perfect information is very rare. Okay, to get the best profit for each condition state of nature is rare to get the best. Okay, so it's come to the additional information to have the result nearer to the perfect information. So we have formulations of having expected value of sample informations of additional informations. So what is expected value of sample informations? So it's the same as expected value of perfect information, which is how much maximum value that you are willing to pay to the agency, to the analyst, to the market researcher. Okay, so how much you willing to pay to get the additional information. So the formulation for EVSI, so this is stand for EVSI, is equal to the modulus of EVWSI minus EVWOSI. Okay, so sample information is the additional information you get from the forecaster, for the analyst, from the agency. Okay, agent. So we look at the first example. So this is from the TV productions. So they want to decide whether they need to produce pilots or they want to sell to the competitor. So it's a one decision to make based on this decision alternative. Okay, so they have three state of nature. Okay, when they produce the pilots, and then they need to submit to the network, television network. So it may be decide, okay, for either 1 years or 2 years, or maybe, okay, it can be reject. So we have three kind of conditions for the produce pilots. Okay, so if another decision is to sell to the competitor, so selling to the competitor will give you profit about 100. So it doesn't matter which state of nature you are, so it still give you 100 because you sell that. So it's actually uh, not affected by the state of nature. But for your understanding, we put this in the calculations, but you still get the same value of hundreds. Okay, so this is given the state of nature, the probability this going to happen is 0.2, 0.3, and 0.5. So this is without additional information. Okay, so another one is the informations when you have additional informations. Let's say you want to have consultations agency, and then they consult you, and then they review the plan, and then they say that it's actually under two conditions. Okay, whether it's favorable or unfavorable, whether it's having excellence or very good review. So excellent is favorable, very good review is like unfavorable. Okay, so means that having additional information. Okay, so you have originally you have this state of nature. Okay, so having additional informations, okay, under two conditions, favorable, unfavorable, or in this case excellent or very good review. So excellent means that the best, which is you have the best condition. So if you see here, okay, the best could be the value from uh, 150. So you can see that from the calculation here, okay, this is what we call as Bayesian. So the probability 0.09, 0.26, 0.65 at the end, okay, is the having state of nature tree given the excellent conditions. Okay, so we know that, okay, when we hire a market researcher, they conduct another research, they say that, okay, actually we have favorable and unfavorable condition. Favorable means it's good for you. Unfavorable means that when the market is not in the good shape, so that is unfavorable. So that's why it's divided by two conditions: excellent, very good. So under excellent, this is the probability, and then under very good condition, this is the probability for each of state of nature. Okay, then you need to construct a decision tree. So decision tree is look like this. Okay, so the first one is the first node, refer to your first decision, whether you pick agency or no agency. So the node, the second node that you see from this tree diagram is the EV value. What is the EV value? Okay, what is the EV value for each node, circle nodes? Okay, so here also we get two. If you hire an agency to have additional information, so you will have the second node here. Okay, so when you hire, there will be two conditions, whether it's excellent or very good. Okay, and then we come to the third node here, 3 and 4. Okay, and also 5 for no agency. So the square notes here, okay, refer to the decision that you need to make. Okay, whether to choose D1 or D2 under excellent condition, whether to choose D1 or D2 under very good condition, whether to choose D1 or D2 under no agency case. Okay, so note here, like I say, it's represent the EV. Okay, so EV for node 6 refer to EV for when having uh, uh, decision 1 given excellent condition. So this is the state of nature S1, S2, S3, S1, S2, S3, and so on. So you can see circle 1, 6, 7 up until 11, okay, is the EV for each decision. Okay, so the last value under the next to the branch, okay, is the payoff value. So this is payoff value. Okay, so it's come from the table just now. So we actually can add another information, which is the probability. For example, excellence. What is the probability here? 0.69, 0.31, and then we have probability given state of nature given excellence 0.09. So this is for this branch, 0.26 for this branch, and 0.65 for this branch. And again, this is the same one because we are from probability given the excellence. So we get the same probability here. Okay, so very good. Given very good condition. So 0.45, 0.39, 0.16, 0.45, 0.39, 0.16. This is also the same. Okay, this is 0.45, 0.39, 0.16. Sorry, this is difference. This is difference because this is when you have no agency, when you will not use additional information. So this is referred to your probability state of nature, 0.2, 0.3, 0.5. Okay, now we need to calculate the EV for each node. Okay, so how can we calculate the EV for each node? For example, having no agency, having no additional information, so we need to calculate the EV for node 10. For example, EV for node 10 is referred to decision D1. Okay, so EV for node 10 is equal to 0.2 times negative 100. Okay, 0.2 times negative 100 plus, okay, summation plus 0.3 times 50 plus 0.5 times 150. So that is EV for node 10. EV for node 11, okay, stand for D2 decisions. So 0.2 times 100 plus 0.3 times 100 plus 0.5 times 100. So you get 100 here. So this one, what is the value of EV? So I already calculate here. So EV for node 10, okay, I calculate for each branch. So the summation is equal to 70, and then for node 11, the summation is equal to 100. So node 10 is for decision 1, node 11 is for decision 2. So from these two nodes, so which you will pick as your final decisions? So you will pick the node with the highest expected value. So in this case, 100 is the highest compared to 70. So this is maximum. So that means we can conclude that, okay, for this question B, recommended decision if the agency opinion is not used. So is not used. So we don't want any additional information. So we will use this tree diagram. Okay. So that's why we calculate EV for this part. Okay. When no agency is used. So maximum node 11, which is for D2. So D2 means that your decision is to sell to the competitor with the expected value of $100,000, or not expected value lah, which is this is the total amount that you will pay to the the total amount that you will get from the competitor. Okay, and then the next one, the expected value of perfect information. So again, EVPI is equal to EVWPI minus EVPI. So where can we get EVWPI? So EVWPI is when we are having perfect informations. So like I say, for every state of nature, we have perfect informations that we say that the best profit will always come. Okay, when we have perfect information, we know that the value of the perfect of the highest profit come from this 100, 100 and 150. Okay, so we need to calculate that based on the EVWPI here. Having perfect information, so 0.2 times 100 plus 0.3 times 100 plus 0.5 times 150. So what the value you get is the EVWPI here. So 125. EVWPI is what you calculate from A. So this is actually equal to EVWOPI. Okay. So EVWOPI is having EV without any perfect information. So it's the normal calculation. So this is your conclusion just now, maximum. So you need to minus with 100. So the total would be 25,000. So this is actually 1,000. Okay, 1,000. Referred to 1,000. $25,000. Okay, worth for perfect information. So this is nothing. Sorry, forgot to delete this. Okay, now determine the optimal decision strategy assuming the agency information is used. So right now we assume that we hire the agency, we hire the forecaster, we hire the market researcher, okay, we hire the analyst. So we need to calculate the EV for that. So agency information is used. So that means this part need to be calculated. Okay, so EV 46789. So under the condition, under the agency, okay, under the additional information, we will have two conditions. When there is excellent condition, so what is the decision? When there is a very good condition, what is the decision need to be made? Okay, so we will have to answer here. The first one is for excellent. Okay, the second one is for very good condition. So for excellent condition, you need to calculate the notes 6 and 7 EV. Okay, so EV 6 and 7 calculate. So this one times probability times the payoff plus probability times payoff plus probability times payoff. So that is note 6. Okay, so you will get this answer. And then for note 7 is the same. This one need to times with payoff plus the branch. Okay, so you will get for note 7, this is the answer. Again, the same step. Which note is your chosen one is the maximum value. Having the maximum value is the note 6. So here note 6 is D1. So under the excellent condition, so the decision is to choose D1. So D1 is uh, produce the pilot. Okay. So if under very good condition, so it's either 8 and 7 notes. So you need to calculate the EV for each note. So probability times payoff plus the branch. This is also the same. Okay. And then you get the EV for note 8 is negative 1.5. The EV for note 9 is 100. So which is the maximum? 100. So that means we can conclude that under very good conditions, so we have the best EV is for condition T2. Okay, so T2 is our decisions under the very good condition. So which is sell to the competitor. Okay, so E, calculate the expected value of agency information. So EV for agency information come from note 2. Come from note 2 here. Okay, so that is EV for agency. So EV for agency come from note 2. So you need to calculate the EV here. So EV is the summation of summation of probability times the value. So right now, uh, for note 2, you need to sum from this note from this branch excellent and very good. So excellent 0.69 time with the EV from the answer maximum just now. Okay, 0.69 times the EV from branch 6. From branch 6 is 101.5. Okay, 101.5 is from branch 6. And then 100 is from branch 9 here. So 0.31 times with the EV from node 9. So you get the EV is 101.04. Okay, thousands. So that is for node 2. Node 2, 101.04. So here is 101.04, the EV. Okay, so EV for node agency just now, your answer for node agency just now is for node 11 here. Okay, node 11 D2. which is 100. The value is 100. Okay, EV 100,000. Okay, so the next questions, find the maximum should pay. So this is EVSI. Okay, sample. Agency information is sample. So EVWSI minus EV without SI. So with sample information, so that means our EV with sample information is this one lah. Okay, 101.04. Okay, so that is our EVWSI. EV without SI, the final one is this one lah. Okay, no agency is without SI. So the answer just now is 100. So minus 100. So it's 1.04, which is equivalent to $1040. So this is the maximum amount the company, willing to pay for the additional information. Okay, so this is the maximum amount to pay for additional information. So determine the final recommended decision for Hale TV production. So it's either this is the final step lah. This is a final decision. Where? Here. This is the final decision. Which EV you need to use? Is it this one or this one? Okay. So with the cost lah. Okay. So determine the final recommended for Hale TV productions. So we know that to hire an agent, so the maximum amount is only to pay $1,040 only. But if you see from the questions, okay, so the value of hiring the consulting agents is 5,000. Okay, 5,000. The fees. So 5,000. So if the fees from agent is 5,000, but the additional information you're willing to pay is only 1,040. So 5,000 fee is very expensive. So it's not worth paying for it, for the additional information. So therefore, the decision, okay, for the Hale TV, the last decision is to just take the no agency lah. Okay. Decision is to sell to the competitor with expected value of 100,000. So this one is you not hire the agency. Okay, so this is question G. Okay, so we look at another example. So this company want to decide whether to manufacture the components part or want to purchase the component parts. So it comes to three conditions, three state of nature, which is when there is low demand, so this is your profit. When there is a medium demand, this is your profit you get. When there is high demand, this is your profit you get. Okay, so with probability of going to happen, this is 0.35, 0.35, 0.3. Okay, so I forgot to explain just now. If you have additional information, okay, if you have additional information, so it's either the best or the worst conditions. So if the best condition or favorable or excellent condition, so that's mean, okay, you will have high increase in the probability of high demand. Okay, so under unfavorable, you will get lower probability of high demand, but higher in the probability of low demand, because unfavorable is not good, market not good, so low demand is high. So if you see in this table here, okay, unfavorable S1, the probability is higher, the highest. But under favorable, the probability of S3 is the highest. Okay, S3 is the good state of nature, high demand. Low demand is the bad state of nature. So that's why when it's favorable market condition, we say that the increase in high demand, probability of increasing in high demand is increased lah. Probability getting high demand is increased under favorable condition. Okay, if you see, this is increase. Okay, this is increase, both, because of the favorable and unfavorable market condition. So that's why we need to 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 hire additional information, but it come to EVSI. Okay, if EVSI is less than the fee, okay, so you will not hire the agent. If EVSI is greater than the fee, so you should hire the agent. Okay, now same step, additional 3 diagrams. So you will have these 3 diagrams of node 1 until node 11. Okay, so this is the same step lah. You need to know how to develop the 3 diagram, to construct the 3 diagrams. Okay, so the same things under the additional informations and without additional informations. Okay, so under additional information, so this is the node. Okay, this is the node 2, and then you have favorable decision whether to choose D1 or D2. Okay, D1 or D2, and then you need to calculate the EV for the state of nature lah. Okay, so every decision have 3 state of nature, 3 market state of nature: low, medium, and high demand. Okay, so the value of probability come from this 0.355, 0.645 is here. Okay, the state of nature probability given the favorable from this table. Okay, and then given unfavorable 0.47 is for this branch, and then no market research is using this probability. Okay, so again, determine the recommended decisions if the market research is not used. Okay, so again, you need to calculate. Okay, the market research is not used, so basically this is for the down here 3 diagram. So need to calculate the EV for node 10 and node 11. Okay, calculate the EV for node 10, EV for node 11. So what is the value? Node 10, 0.35 times 20 plus negative 20, sorry, negative 20 plus 0.35 times 40 plus 0.3 times 100. What is your answer? So the same probability but different payoff. 10 plus 45 plus 70. So what is your EV? So from this, which give you maximum value? Okay, so What is the decision? Choose what? So based on maximum value for this one. Okay, compute the expected value of perfect information. EVPI is equal to EV with PI minus EV without PI. Okay, so the B answer here is for EVWOPI, the expected value. And the expected value with perfect information is come from the table here. Under perfect information, for each state of nature is having the best score of profit. So 10, 45, 100. So 0.35 times 10 plus 0.35 times 45 plus last one 0.3 times 100. What you get? And then you can calculate the EVPI. Okay, so EVPI, this value minus this value, which is the maximum. Which one? This one or this one? So that is EVWOPI. Okay, determine the optimal decision strategy when the agency information is used. So when we have, the market research lah. So agency here means the market research is used. So we have to condition whether it's favorable condition and unfavorable condition. So favorable condition is note 6 and note 7. So EV for note 6 is equal to 0.2 times with negative 20 plus 0.3 times 40 plus 0.5 times 100. So that is for note 6. 0.2 times negative 20 plus 0.3 times 40 plus 0.5 times 100. So what is the answer? And then EV for note 7 is the same probability except for the payoff is different lah. Plus 0.345 plus 0.570. What is your answer? So this one and this one, which is maximum? Which is maximum? So choose either note 7 or note 6. Which one give you the maximum value? Okay, so the next one is the same. Unfavorable. So unfavorable is from this unfavorable. So you need to calculate the EV for note 8 and note 9. Okay, EV for note 8 and note 9. EV for note 8 and EV for note 9. So EV for note 8, 0.47 times with negative 20 plus 0.33 times with 40 plus 0.2 times 100. Then what is your value? And then for the note 9, the same probability, different payoff. 0.33 times 45 plus 0.2 times 70 is equal to what? So which is maximum? Okay, which is maximum? So you can say that choose note 8 or note 9. So decision 1 or decision 2 based on the maximum value. So I leave it to you to answer the empty space here. Okay, the next one is expected value having market research information. So the notes from the tree diagram refer to this one lah. So 0.35 expected value for node 2 is 0.35 times with what? Plus 0.645 here. Okay, here times with what value? So what is the value need to be put here? Is come from the node 6 or node 7 EV. So which is the maximum for 6 or 7? So you put in the value here, and then which node 8 or 9 is the maximum EV, you put in the second one. Okay, so you get the answer here. So you can see that favorable for node 2, 0.355 times whether this one or this one punya EV, or unfavorable, and plus, okay, plus, we know that node is the summations of probabilities times the payoff. So for node 2, we have two nodes here. Favorable time with EV either 6 or 7 plus unfavorable time with EV for 8 or EV for 9. Okay, so you get this value. Okay, so this is wrong. This is from before. So the maximum fee the company could pay. So again, this is EVSI is equal to EV with SI minus EV without SI. So EV with SI is from node 2. Okay, so this is EV with SI. And then EV without SI is from either this or this. So which one is the maximum? Okay, so that is EV without sample information. So you get the answer for EVSI. Okay, so determine the final recommended decision for the company. Okay, so the note 1. So that's mean if you if if he choose to have market research, because here we don't have any information regarding the fee. So let's say we have if the fee for additional market research is $2,000. So what is the conditions? So if the fees is greater than the what EVSI, so we can say that no market research, not worth. Okay, so no market research, that's mean we will have no market research with what decisions? Either D1 or D2. Okay, either D1 or D2 here. Because I don't know the answer yet. Okay, so which is the maximum? For example, under the no market research, the decision is for D1. So here, okay, no market research been conducted. So that means they decide to choose D1 if this is the maximum. Okay, so if the fee is less than EVSI, so we take market research. Okay, we take the market research with the EV equal to the value here. Okay, market research here. So they have, when we conduct market research, so they have to condition lah. Okay, favorable and unfavorable. EV with favorable condition, choose D1 or D2. Or unfavorable condition, choose D1 or D2. Okay, so it's up to the answer from here. Okay, from D. Okay, so that's all for this part. So exercise 3, I will leave to you to solve the problems. So if you finish answering example 3, so if you want me to check it, the answer for you, so please send me your answer later. Okay, so that's all for chapter 6. So hopefully you will understand how can how you can decide, make decisions based on the criteria given. Okay, so that's all for this chapter. Thank you for listening.